Good evening, students. Good evening, students. Amanjok, second. Good evening. Just hold on a second. We'll wait for others. Good evening, students. So we are discussing circles. Am I right?
Yes, sir.
So we done first exercise also. Anything pending from the first exercise? Just a minute. I will open the document. Let's see. So last session we are discussing about the basics, definitions of the different lines, and what is a circle, what is a tangent, what is a secant, what is a chord, and everything we discussed. Now, a few points we are going to discuss today about the tangents. Our scope of syllabus is only theorems related to tangents and how to calculate the length of the tangent drawn from a point. So before going to this, a few basic points which will be valid for most of the MCQs we'll discuss now. First point, we already discussed yesterday. How you can say, suppose I draw a circle, this is a plane. I draw a circle, there is a circle in this plane. How I can say the point is inside the circle, outside the circle, on the circle. Suppose if I'm marking a point. By seeing this is a circle, center O, and the blue color line circles is a circle. And there is a point P here. How I can say the point P is inside circle, on circle, outside circle. how I can say mathematically, what kind of relation can say the point P is inside the circle, sir? The point P is outside the circle. The point P is on the circle. Anyone? Sir, you can see now you are only drawing on the board. Straight away, I can say the point P is outside the circle. Other than this, with the equations, how I can say? Without drawing, with general mathematical statements, how I can say? It is inside circle, it is outside circle, it is on the circle. Students, please respond. Students, question is for you only. How I can say? Without drawing the circle, how I can say the point is inside, outside, or on the circle? Anyone? Any clue from anyone? Aditi, guys, yes or no or something? Amruta, Harita, Vaishnavi. Anyone? Akshita, Arman, Adarva. Guys, say yes or no something. It's very simple. I'm taking 3 points. P, point Q, point R. And OA is the radius. I'm taking radius is R. I joined O to R, O to Q, and O to P. P is somewhere here. So without drawing the circle, without how I can say, if a distance, like the distance between the distance between the point and center will decide whether the point is whether the point is located in which point location, I can say point location, whether the point is inside or outside or on the circle. Anyone? With respect to this discussion, anyone can tell? Here, if you observe, OP is greater than radius, then I can say if the distance between center and the point is greater than radius, then P is outside the circle. The distance between the point and the center, OQ, is equal to radius, then I can say Q is on the circle. Correct. If you look into, suppose you are taking capital R, OR is less than radius. The distance between point and center is less than radius. That particular point is inside the circle. So that relation between distance from the point to the center and radius will use the position of the point, whether it is inside or outside or on the circle. I can say the relation between the distance from center to point, from center to point and radius will give the location of the point. There are only three possibilities, whether it is inside the circle, whether it is outside the circle, whether it is on the circle. Location of the point. Is it clear, guys? Based on this, we are having questions, MCQs and one more questions came. They didn't draw a circle. That they will say, they will give the radius and they will say the distance between the point and that center is this much. Can you identify where is the location of the point, whether it is on the circle, outside the circle, or inside the circle? None of the above. Like that kind of questions come. Is it clear? A little bit related to our upcoming topic.
Understood, sir.
Now, anyone can recall the definition of tangent? When I can say this line is a tangent to the circle. Tangent. How we can define?
Sir, it is a line which intersects a circle at only one point.
Instead of saying intersection, I can say which will meet the circle at only one point. Which will touch the circle. It won't intersect. It's a line, it's a secant which is intersecting the circle at one point, or a line drawn which will meet the circle, which will touches the circle at one point. That is called tangent. Now, the deal is, suppose if I am saying this is a plane, three ways I can locate a point. What are the three ways I can mark a point? One is the point might be outside the circle. Second point is the point might be on the circle. The third point is the point might be inside a circle. These are the three situations only we can able to face. Other than this, there is no option the point can exist in a plane. Will you agree? Other than this, is there any situation you can able to locate a point in a plane?
No, sir.
From the definition of the tangent, the points on the tangent always lies outside the circle or on the circle. If I am taking any point on the tangent, those points, the point might outside the circle or on the circle. So that is the definition of all the points on the tangent. If you see this diagram, the tangent is just only one point is on the circle, rest of all the points are outside the circle. That means that point is the radius. The point which is common to the tangent and circle is called point of contact, and the distance between the center and that point is known as radius. Rest of all the distances are more than radius. That's the reason those points are outside the circle from the previous discussion. Now our topic is number of tangents drawn from a given point. So there are three possibilities the point can locate. One is the point lies inside the circle. Suppose the point is lies inside the circle. I can't draw any tangent because the tangent points are always lies outside or on the circle. So, but the point is lies inside the circle. The point P is inside the circle. So, number of tangents is 0 here. No tangent can be drawn if the point lies inside the circle. Is it clear? This point is clear. If you are okay, I will move to the next point.
Yes, sir.
The next one is, if the given point is lies on the circle. Now the situation is like this. This is a circle and the point is P is here. So I can draw only one tangent. I can draw many lines which is passing through this, but there will be one line can touch the circle without intersecting any other point. How I will know? I can draw many lines which will intersect and which will pass through the circle. It might be act as a secant. So number of tangents drawn from a point if the point lies on the circle is equal to 1. Hope you are clear. Why I can't draw more than one here? Because my given point is P, which is lies on the circle. So the circle should pass through the point and also tangent should pass through the point. So only one tangent can be possible here. Is it clear? Shall I move to the next point? Students, are you clear? I can move to the next one.
Yes, sir.
If the point is outside, the remaining case, point P lies outside the circle. The point P lies outside the circle. Suppose this is a point P, I can draw two tangents. One tangent is like this, and the tangent is like this. Pair of tangents. So it is meeting at T1, it is meeting at T2. This is center O. OT1 is called radius, OT2 is called radius. This is always at 90 degrees because the shortest distance is always perpendicular. That's theorem we already proved in the last class. The line drawn from center to the point of contact of a tangent is always perpendicular to the tangent. So PT1 and PT2 are most or maximum two tangents can draw from a point outside the circle. Is it clear? So these are the 3 points also very much valid with respect to the diagram. You can able to remember number of tangents can able to draw from a given point, which is inside, which is outside, which is on the circle. Is it clear? Friends, anyone having any doubts, please?
Understood, sir.
Now, with respect to this, we are going to discuss one theorem. In this case, length of the tangent can able to explain only if the point is specified. In the third case only, we can explain the length of the tangent. If the point is outside the circle, if I am drawing the tangent, the distance between the point and point of contact is known as length of tangent. PT1, the line segment of PT1 and PT2 is known as length of the tangents. Length of the tangents drawn to the particular circle. Now, why I am explaining the definition of the length of the tangent? Our theorem is related to length of the tangent. Most of the questions related to third case. Second theorem from this chapter. The theorems are very simple here. Theorem 10.2. The statement of theorem is the lengths of tangents drawn from an external point to a circle are equal. That means if I'm taking the previous diagram, the third case, the statement says, what is the statement says, students? What is the statement says? The statement says the length of the tangents PT1 and PT2 are the length of the tangents. Drawn to the same circle, because from P, this is a circle C, PT1 also to the circle C, PT2 also to the circle C. So length of the tangents drawn from an external point to the circle, to a circle, are equal. So he is saying PT1 and PT2 are tangents, and if I am drawing from an external point to a common circle, I can say PT1, length of the PT1 will be equal to length of the PT2. This is what I have to prove. This is needed to prove. So this is my construction. From the center to point of contact, join. Join from O to T1, from O to T2. So how we will prove? Here we are using concept of congruency of the triangles. So what is the proof? Is it clear, the statement? Is statement is clear, students, everyone? Students, is the statement is clear?
Yes, sir.
Proof is very simple. We have to prove PT1 is equal to PT2, and construction. join from center to point of contacts. So this is a diagram. Construction is joined from O to T1, that is OT1 and OT2. We have to draw. OT1 is equal to OT2 is equal to radius. Are you clear what I'm saying? And OT1 is perpendicular to PT1. OT2 is perpendicular to PT2. The reason is same. Radius of same circle, here is the reason. What is the reason here? What reason I have to write here? Angle between radius and tangent is 90 degrees. We proved in a earlier class. So now the triangles are like this. There are two triangles formed here. OP is equal to OP, common side. This is P, O, T1, 90 degrees. T2, this is 90 degrees. So OP is like an hypotenuse here. I can say triangle OT1P is congruent with triangle OT2P. The reason is right angle triangle property, RHS. Right angle hypotenuse side. Right angle hypotenuse side congruency. So from here, PT1 is equal to PT2 from CPCT. So PT1 is equal to PT2 means the lengths of the tangents drawn from a point to a circle is same. Is it clear, students? How I proved? It's a very simple proof. Just already we know the tangent is perpendicular to radius line and OP is the common side and both the angles are right angle triangles and OP is hypotenuse. So right angle is there in both the triangle, hypotenuse is common and side is same. OT1 is equal to OT2. From that, I can say these both the triangles are congruent to each other. If two triangles are congruent to each other, corresponding sides are same. Corresponding sides is other than radius and hypotenuse, remaining is PT1 and PT2. I can say PT1 is equal to PT2 from corresponding parts of congruent triangle. Is it clear? Anyone having any doubts, please? Students, is it clear? Shall I move to some numericals based on this?
Yes, sir.
So here one point you have to keep it in mind. If the point is outside the circle, if I can draw two tangents and the length of the tangents are same. So I'm moving to the exercise 10.2 to discuss a few numericals related to this theorem. Most of the questions related to this theorem only because there is only one theorem based on this. So 3 questions are MCQs. Question number 1, 2, 3, choose the correct option. From a point Q, the length of the tangent to a circle is 24 centimeter. That is, the first question says TP is equal to TQ is equal to 24 centimeter. And the distance Q from the center is, so OQ is equal to OP is equal to radius, that is equal to 25 centimeter. The radius of the circle. This is the radius. This is the radius. Then the radius of the circle is asked. No, wait. The distance Q from the center is 25 centimeter. No, this is not the diagram. The diagram is like this. This is the circle. From a point Q, the length of the tangent. The Q is outside. They draw the tangent like this. And radius is 25. Length of the tangent is 24. No, wait. Sorry, guys. I will take only this question. Yeah. So completely, the given diagram is not related. There is a circle. And there is a point Q. From a point Q, the length of the tangent to a circle is, this distance is 24 centimeter. It is meeting at T. This is 24 centimeter. Center is O. If I join from Q to O, this distance is 25 centimeter. Is asking radius. That means they gave QT is the length of the tangent, 24 centimeter. QO is the line joining from the Q to center, 25 centimeter. So OT is equal to radius. Here, triangle OTQ is right angle triangle. Why right angle triangle? The radius always perpendicular to the tangent. If I am extending this, the angle between, since the angle between tangent and radius is 90 degrees. So I can apply Pythagoras theorem here. OT square plus QT square is equal to OQ square. OQ is hypotenuse. I need OT square is radius. So radius is equal to 25 square minus 24 square. Anyone can calculate and let me know the answer. What is the answer you are getting? Students, what is the answer? From this calculation, what is the answer? Arman, Adarva. Harita. So far, are you clear? Students? Aditi? Guys? Yes or no? Students will able to hear?
Yes, sir.
Yeah, what is the answer?
Sir, radius
Radius is
7 centimeter.
7 centimeter. You will get root 49. 7 centimeter is the radius. So I'm moving to the next question. In the figure 10.11, this is a figure for this question. TQ and TP are the two tangents to a circle center O. So that angle POQ is 110 degrees. Then what is the angle PTQ? PTQ. This is 90. This is 90. And this is 110. And OPTQ is a quadrilateral. So 110 plus 90 plus 90 plus angle T is equal to 360. Because of the quadrilateral, sum of all the angles in a quadrilateral is 360. With that concept, I can able to calculate how much it is. Or if I'm drawing a tangent, the angle between radii and tangent is 90 degrees is fixed. So the angle formed at the center and angle between the tangents is always 180 degrees. Based on that also you can say angle O plus angle T is always 180 because these two are 90 degrees fixed. If it is 110 degrees, so angle T is equal to 180 minus 110, that is 70 degrees is my answer. Either you can do in this method, either you can do in this method. Hope you are clear what I am trying to say. There are two ways you can able to discuss from the concept of triangles or from the concept of quadrilaterals. Is it clear? Students, are you clear? It is 70. So try the third question by your own. I will give few minutes time. Please complete the third question, question number 3. First, try to depict the diagram for the given situation. Circle a point P to a circle with center O are inclined to each other at an angle of 80 degrees. P is a point, PA, PB are tangents from a point P. It is possible only if the point is outside. He's saying PA, PB. Center O are inclined to each other at an angle of 80 degrees. This angle is 80 degrees. Then what is the angle POA? He is asking angle POA. This is 90. This is 40. And automatically you can able to calculate this is 50. How? Anyone can explain how I wrote the answer is 50? Here we have to understand, if I am joining the point P to O, the angle between the tangents will bisect by the line joining of center to the point P from the congruency of the two triangles. If I am saying these two triangles are congruent, the angle should be same. If the angle should be same, it is possible only if it is bisects. Students, are you clear what I am saying?
Yes, sir.
So the angle between two tangents is 80 degrees. So this is 40, this is 90, and automatically this angle is 50. So the answer is 50 degrees. Next one. Prove that the tangents drawn at the ends of a diameter or of a circle are parallel. This proof I will explain. It's like a theorems. Prove that the perpendicular at a point of contact to the tangent circle passes through the center. Yeah, we'll see from 6th onwards. The length of the tangent drawn from a point A at a distance 5 centimeter from the center of the circle is 4 centimeter. What is the given data, students? Suppose this is a point P. Drawn like this. This is the center of the circle. What is its meaning? What is the given data? Anyone can tell, and it is meeting at A. What is the given data? Srikanth. ఇంట్లోనే ఉన్నా ఇంట్లో ఉన్నా Sorry guys, what is the given data? Harita, anyone can respond? Vaishnavi, Sanyu. Length of the tangent from a point A, this is A, at a distance 5 centimeter from the center. So if I'm taking this is the point T, AO is 5 centimeter. From the center of a circle is 4 centimeter. The length of the tangent from a point A at a distance 5 centimeter from the center of a circle is 4 centimeter. So sorry. So length of the tangent is 4 centimeter and point is 5 centimeter from the center. It's clear. Is asking radius. So OT square is equals OA square minus AT square. So 5 square minus 4 square is equals 25 minus 16. It is root 9, 3 centimeter. So the radius is 3 centimeter. Simple questions. Only the understanding the question is a little important here. 7th question. Try to solve the 7th question. Two concentric circles of radii 5 centimeter and 3 centimeter. I will give the diagram. Try by your own how to complete this one. Concentric circle means two circles having the same radius. Sorry, same center, not same radius, same center. The center of these two circles are same with a different radii. Suppose center of the circle is O. One circle radius is 3, another circle radius is 5. Find the length of the chord of the larger circle which touches the smaller circle. It is like this. Is asking AB value is how much? Where AB is the tangent for the smaller circle because it is touching at the smaller circle, which touches the smaller circle. Tangent for smaller circle, and also the same AB is chord for the larger circle. Try. The logic is from this diagram you have to form a triangle and join A to center, B to center. We know OA is equal to OB is equal to 5 centimeter, which is radius of the larger circle, radius of bigger circle, and the contact point is C. OC is equal to 3 centimeter, radius of smaller circle. OC is perpendicular to AB. Since AB is touching smaller circle, so we can say AB is the tangent. So the tangent is perpendicular to radius. With the help of this, I can calculate BC square is equal to OB square minus OC square. Same as AC square is equal to OA square minus OC square. Calculate from here BC, from here AC. So AB is equal to AC plus CB. Find out the answer. Let me know what is the answer. Please let me know what is the answer.
The answer is 8 centimeters, sir.
Yeah, OB square is 5 square minus 3 square. It is 4. Here also 5 square minus 3 square, it is 4. So 4 plus 4 is equal 8 centimeter is the answer. AB length of the cord is 8 centimeter. Anyone not clear? Please let me know. I will explain. Please. Is it clear? Shall I go to the next question?
Yes, sir.
Next question is he is asking 10.12. So this is not the figure you have to consider. This is not the figure. If you look, ABCD is a quadrilateral, circumscribed a circle. Prove that AB plus CD is equal to AD plus BC. AB plus CD. It's very simple. AP and AS are tangents drawn from A to a circle. So from the theorem, I can say AP is equal to AS. First equation. Will you agree, everyone? Same as DR and DS are tangents drawn from D. So DS is equal to DR. Second one. Next one is CQ and CR are tangents drawn from C. So CR is equal to CQ. Third equation. Same as from B. BQ and BP are tangents drawn from B. So BQ is equal to BP. Fourth equation. I'm taking LHS. Is asking us to prove AB plus CD is equal to RHS is AD plus BC. What is AB value? AB can be written as, I'm taking LHS, AB plus CD. AB can be written as AP plus PB. See here, AP plus PB is AB. And CD can be written as CR plus DR. And AD We know AP is equal to AS. This can be replaced as AS and CR can be replaced as DR. Students, are you clear? Are you following what I'm writing here?
Yes, sir.
And same as PB can be written as, we need BC here. So PB can be written as BQ. And DR can be written as CR plus DR. DR can be written as DS. CR can be written as CQ. This is wrong. Are you clear what I'm saying? AP can be written as AS because AP is equal to AS. AP can be written as AS from here. PB can be written as BQ from fourth equation. This is from equation 1. This is from equation 4. This is equation from 3. This is equation from 2. So from here, AS plus SD. AS plus SD I can write as one set. BQ plus CQ can be written as another set. AS plus SD is AD. BQ plus CQ can be written as BC, which is nothing but RHS. So these 4 points you have to highlight, very important, because from these 4 points only we are altering the LHS. So this is how we can prove this question. Are you clear, students, so far? Is it clear? Anyone having any doubts? Please respond. Shall I wind up the session? Yeah, please practice some more questions. A few questions left in this topic, and we will come with some extra questions after completion of the topic. Only very few questions. Next class we can wind up the circles, and we will do some extra numericals if time permits. Yeah. Shall we meet in next class?
Yes, sir.
Yeah. Bye everyone.